Yeah, when I started the meeting, now it is started soon.
So good afternoon, all the students of Design of Power Electronic Converters. So before taking up the questions that I received, I would like to take live questions. So if you have any questions, please raise your hand and then you may ask your question. And it will be better if you can turn on your video, because especially I did it on Teams with the intention to interact with the students. Yes, Ravi Kumar, please go ahead with your question.
Yeah, good afternoon, madam. My question is regarding the controller aspect of the power converter. So, which type of converter is like a controller is better? Like there are many like FPGA, DSP, and microcontrollers. So, when it comes to practical design, which type of a controller is better suited for the programming?
It depends mainly on two things. One is your switching frequency, and second is how intensive the controller is, the action the controller is supposed to perform. Like, for example, if it's for very small DC to DC converters, then where the control is relatively simple, but the switching frequencies are very high. There, people go for analog control. They don't even use any microcontroller, DSP or FPGA. I mean, they don't use digital control. Whereas if you need to do digital control, that means you have more calculations to perform by the controller. Then, depending on your switching frequency, people may go for microcontroller, but microcontrollers' capacity of computation is usually less. So for electrical drives applications and many of the power electronic converters, presently they use DSPs. And if we go for further high switching frequencies and the control is so involved that we want parallel computing, then we can also go for FPGAs.
Okay, ma'am. Thank you very much.
Anybody else wants to ask a question now?
Hello, ma'am. Can you hear me?
Yes. Can you please raise your hand?
Yes,
so
ma'am.
that I know who is asking the question.
Yes, ma'am. I'm Navjot Acharya.
Yes. Yeah, please tell me.
Good afternoon, ma'am. First of all, ma'am, in electric vehicles, generally the AC motors are used, and to control the speed of AC motors, mostly the input frequency and input voltage to the motors need to be changed, which can be done by the VFD, which is variable frequency drive. But it might be costly to use 4 VFDs for 4 AC motors. So, means how to design an inverter that can convert DC to AC with the desired output frequency and voltage, which must be controlled with the accelerator. So, which means when we press the accelerator, the frequency of the output frequency from the motor, from the inverter, should increase so that the motor speed should increase. So can we do that in the inverter, which can be means the frequency of the output frequency of the inverter can be controlled by the paddle. So is that possible
Okay.
to do in the
See,
inverters?
what I see is that your question is specific to some particular application, and
Yes, ma'am.
I'm not sure if I'm able to follow everything that you are telling. So it is better if you draw a diagram of your application and what is your requirement, and you can send it to me. Then I'll see that based on that, what actually may be suitable. Okay, I think you had also posted the question on Google Sheets. Uh,
Yes, ma'am. Yes.
Yeah, so it is better if you draw a diagram, because just you stating like this, it is very difficult to understand what exactly your application is and what is its requirement. So draw a proper
Okay.
block diagram and write the functionalities it is supposed to perform, and then you send it to me. I'll see if some solution can be thought of.
Okay. This was the first question, and then second question was that if we are converting and that is converting AC to DC. So while converting, we will be using edge bridge rectifier, and then we will use a capacitor to filter the means that voltage to completely filter it to DC, and then we will use a regulator to make it perfect DC. So how to calculate the value of that capacitor so that we can achieve our desired output. So
See, mainly your capacitor value, preliminarily, it is decided by the value of the ripple current. So later on in the course, towards the last module, I'll give you a detailed description about capacitors, what are all the different specifications that are important to choose a capacitor. But when you just want to decide the value of it, first thing that comes in is how much ripple current it has to handle. So based on that, you will get the first idea what capacitor may be suitable. And next is that how much energy storage it has to have. Means on one side, energy is being pushed to the capacitor, and on the other side, it is being utilized. Like you're from AC side, whatever. I mean, you're having an edge bridge, and then some kind of a ripple is coming, and then on the other side, you have a DC load or some other inverter type of load. So, what is the ripple that is happening? And the ripple in the current, and also the ripple in the voltage. That also decides the capacitor value. You might have seen there was a question related to your value of capacitance for buck converter.
yes,
So, yes, so there, if you go through those lectures, there your ripple in the voltage delta V, how much is the percentage that you are using, that relaxation is given, like 1% ripple can be afforded or 2% ripple can be afforded. What is the ripple that you can afford for your particular application? Based on it, your capacitor is chosen. And there, of course, there is a relationship of that with the ripple current, because it is the ripple current which actually leads to the ripple voltage. So that is one very basic thing by which your capacitor, initially the value can be estimated. But of course, you also have to see how much energy storage you need. It means your half CV square. That also is sometimes seen. It depends if you have a motor type application or braking application, some amount of energy of the capacitor has to be all of a sudden given. So that also you have to see. So these two things you should initially look, and more importantly is after you do the calculation, you simulate it. There was a simulation exercise given, an extra
yes,
problem given.
ma'am.
So if you simulate,
Yes, ma'am.
then you can test that whether that value works or not. Because in practical case, you will have several non-idealities. So in simulation, you can put some of the non-idealities and see whether this value is good or you should go for higher value, or even lower value will also work. That is how you can do it.
Okay. Thank you.
Yeah, I think there was another hand which was raised in between while I was taking Navjot's question. So if somebody has raised the hand, can raise it again. Yes, Ankur.
Hello, hello,
Hello.
Ma'am, I am working on this Statcom application. In that, I am using my controlling frequencies more than 5,000 5,000 kilowatts. So which device will be suitable? Either MOSFET or IGBT. Which can be
5,000 hertz or 5,000 kilohertz?
sorry 5 kilowatts. Sorry 5 kilowatts.
5 kilohertz. And how much
Huh.
is the power rating?
Power rating are 3500 MVA. Hello.
3 MVAR.
3500 MVA. As per the
I
simulation.
am not able to get it. How much is the voltage output?
Sorry, ma'am. It is actually 3500 VAR. 3500 VAR. Volt ampere reactive. It will be used as a bidirectional compensator. So which device can be utilized?
How much is your current output?
Output current is 12 ampere. In the simulation, it is showing 12 ampere after the compensation.
And what is the voltage level?
Voltage level is 415.
How much?
415. Line to line AC side 415 and DC side it is 650 volt.
Okay, you can go for IGBT.
IGBT.
Yes, actually MOSFET also in this, you may be able to get it because 650 volt, that means you need about higher voltage, 900 volt or 1200 volt MOSFET is what you'll be needing. And MOSFETs usually you will get for 600 volts and the current range are usually higher. So MOSFET, I'm not sure if you will be able to find out one. You can see, but definitely IGBT you should be able to find out.
Okay, ma'am. Thank you.
Okay, means if you have, I mean, assuming your output current is 12 ampere, and let's say
Actually,
the
ma'am,
peak,
I have
whatever it is going 15 or 18 or 20 amperes. So you have to have a safety margin there. So 20 amperes, like 30 or 35 amperes IGBT you can take, 650 volts. So you just see you can get a 1200 volt, 30 or 40 amperes IGBT, and do check the turn on times and turn off times, and for what switching frequency the manufacturer is recommending, that you see in the data sheet. But definitely you will use IGBTs.
okay, ma'am. Thank you. Thank you so much.
Yes, I think Omkar, yeah, Omkar, please go ahead with your question.
Hello, good afternoon, ma'am.
Good afternoon.
Yes, ma'am. So I wanted to ask, like, if I'm designing a automotive traction motor controller, like basically an inverter. So in that my system voltage is 96 volts. So I want to know like how the switch selection can be done, like whether I should go for IGBT or whether I should go for MOSFET, and how this is done in practically means that I wanted to know.
Okay. Because I'm getting more questions on the selection of devices. So let
Yes,
me give a general answer so that,
yes,
I mean, everybody who is having this similar question, they get to know what they have to choose. So presently, if you want to use silicon devices, then if you have to choose between MOSFET and IGBT, MOSFETs are usually used for relatively lower voltage and higher current requirements. And your switching frequency also can be higher. Higher means you can go for 40 kilohertz, 50 kilohertz, like that, and even higher than that is also possible. So when voltage is relatively low and currents are higher, and for those applications, MOSFETs are more suitable. And where you have like relatively higher voltages and also the currents are also relatively high, For medium power applications, there IGBTs are used. But IGBTs cannot be switched as fast as MOSFETs. So there, depending on your power rating, you can switch like from 1 kilohertz to like about 40 kilohertz is what is the range in which IGBTs are used.
Okay.
Is that, does that answer your question?
Yes, ma'am. But are there any boundaries like this one? This voltage level is considered as high voltage, or this power level is medium power level, or this power level is high power level, like that? Are there any boundaries specified, or?
Actually, that is not what you should ask, that what is high voltage or what is low voltage or what is medium voltage. Those are relative. Strictly speaking,
Okay.
they are relative, and that terminology, if you go by them in different scenarios, people use it interchangeably. So
Yes.
how do you now find what device you should use? For that, what you have to do is you have to search for different MOSFETs and IGBTs datasheets. Whatever
Okay.
you need, whatever your voltage and current requirement are, you give a safety margin of it. First of all, you find out what is the peak current that your converter has to handle and what is the peak voltage it has to handle. And then you have a safety margin of, let's say, 1.5 to 2. And
Okay.
then for that, you look for MOSFETs as well as IGBTs. If you choose IGBT, then your switching frequency will be relatively lesser. You can't go to hundreds of kilohertz. And if you choose MOSFET, you can go for higher switching frequency. So based on that, then you will decide which is the device that you will select. Whatever theoretically we may say what is low, what is high, and whatever theory we may talk, ultimately, you're not going to make a MOSFET or IGBT. You will buy it based on whatever is available in the market. So a very easy thing to do is go to the e-commerce websites where many of the manufacturers are selling their MOSFETs and IGBTs. Like you must be knowing DigiKey, Element
Yes.
14,
Yes. All
RS
there. Yes.
components, and so forth. So there, actually, you can go put your specifications, and on many of them you will actually get to choose. Like you will have the what is called as the drop down menu.
Sorting. Yes, we can do the
Yeah,
sorting
you can
as well.
put the range,
Yes.
and then you will see many of the MOSFETs or IGBTs. They will search and they will give you, and then you go to the data sheets and you see that whether whatever is given in the data sheet are those specifications suitable for you or not. If it is, then you can select that particular device. That is how you decide what is the device that you have to use for your design.
Okay. Okay. Thank you, ma'am. I got my answer.
Okay, thank you. Yes, Puranish.
Ma'am, hi ma'am. My doubt is like why gate resistors are that much important in while switching turning on or turning off of any devices.
Okay, I don't see anybody's video. I think last 2, 3, I didn't get to see them. I'm not sure if you people are turning on the video. If you're not, please turn it on. That is why I held this session on Teams rather than on YouTube. Okay, so yeah, so now coming to the question that why is gate resistor important? Because the MOSFETs or the IGBT, your gate emitter junction or gate to drain junction or gate to collector, there, if you recall those lectures, there are capacitances involved in it. So those capacitances are charged and discharged during the turn on and turn off process. So now you will have to have some resistance. Even if you say that I will not put any resistance, you will be soldering it on a PCB or you will use a bus bar structure, whatever you're going to use, it will have its own resistance. So eventually you are putting some resistance or whatever casing you're going to use, the leads are going to come out. That also has some parasitic resistance. So there is an RC. And so now if you put another, R value that is going to affect the charge and discharge process of the MOSFET or the IGBT. And so it will affect the turn on and turn off times of the device.
Okay, ma'am. Okay, clear.
Ma'am, good afternoon, ma'am.
Good afternoon. Who is asking the question?
Ma'am,
Venkatesh.
Venkatesh.
Yes.
Ma'am, actually, in this course, we will come to know whether we will come to know about the controller design, ma'am.
No, controller design is not covered in this course because controller design is very specific to the converter. So because this is a general course on design which you can apply for any converter, so that's why controller is not going to be covered as of now. Okay.
Okay, thank you, ma'am.
Good afternoon, madam. This is Selva Kumar, madam. Madam, do we is there any chance to cover that boost converter and buck boost converters, madam?
No, that is not possible. Although the design you learn for buck converter, for buck boost and boost converter, you can design it on similar lines.
Okay.
It is just the converters waveforms that you have to study separately, and then use exactly the same procedure. All the steps, remaining steps are same. That is being covered in this course. So your buck converter and edge bridge converter are just been taken as examples to explain design concepts. It is not that you can design only these two converters using whatever this course, this course teaches. Okay, you can design any other converter.
Okay, thank you.
Yes, Ravi Chandra. Please go ahead with your question.
Ma'am, in optocoupler based isolators, we are using insulation, ma'am. Means you have mentioned that if you don't use insulation, it may affect the total process. But I want to know what is the exact how it affects the system if you don't use isolation. And also I want to ask that like in PV inverters, if you don't use isolation, it will cause leakage current and it affects the system. Is it the same thing in gate drives also?
No, you are mixing up two things. PV inverter, why, you need isolation and the leakage current that is associated with PV, that is a different thing. Okay, so here what we are talking about is isolation is specifically needed when you have a high side driver. If you remember your edge bridge, one leg if you take, then the transistor which is connected to the negative bus, for that even if you don't give isolation it is fine, but for the upper one you need isolation because the midpoint of it, the leg voltage, the midpoint, that is floating. So there you have to have some isolation. This is what you can say, that it is something that is needed. You have to, even if you don't give isolation, you have to go for bootstrapping technique. So that is, as far as the need is concerned. Now, apart from the need, there are other practical aspects also which are involved. And that is related to your noise issues and electromagnetic interference issues, and the common mode transient immunity CMTI problems that somewhat discussed in the driver's part. So that's like a noise from the power side goes to the control side or to the sensing side. and then that can create a lot of interference in your switchings. So that if you don't want, for that also people prefer isolation.
ఏమిటా క్లీనింగ్లు?
Okay, ma'am. Thank you.
Anybody wants to ask any other questions now? Yes, Bakshi Ishan, please go ahead with your question.
Madam, good afternoon. I'm very sorry I cannot turn on my video camera because I am in different location. I am not allowed to do so. I had one doubt with the VFDs which we are using over here. Sometimes that VFDs are installed in applications like passenger hoist and tower cranes and all sort of stuff. In that drives, we have this dynamic braking principle. Okay, we are using dynamic braking when that equipment is coming downwards. So I want to ask whether that dynamic braking is having an effect on filtering capacitors, because that particular sort of load is taken from the DC link which is provided in the rectifier. So I want to know on that thing.
No, when you say effect, what kind of effect are you talking about?
Sizing, madam, capacitor sizing.
Yes, definitely. You have to consider all the dynamics of your system while choosing it. Only by steady state, we definitely choose your values of filters, means your LNC can be chosen initially based on your steady state equations. But when you have some dynamics, you're supposed to simulate your system and also see what are the transients that are happening in your system, and whether any of the components that you have chosen, they are getting affected by that. So that is definitely something you need to do before you choose your value of filters.
Okay, madam. Thank you, madam.
Yes, Sagar?
Yes, ma'am. Can you hear me?
Yes.
Yeah. So, ma'am, currently I'm doing, yeah, first of all, good afternoon. And currently I'm doing my master's in electrical vehicles. So for electrical vehicles, I'm studying different aspects, like for the design of the battery management system, inverters, and battery motor controllers and everything. And each part includes having a power electronic devices. So how does, like when we are designing, the initial steps of designing a power converter, considering different aspects of electric vehicles. So how is it done? What could be the process? If you could explain.
No, I didn't get your question. What process you want to know?
Yeah, like the different aspects of electric vehicles includes power electronics devices, like for designing a power management system for battery, for inverters, for motor controllers. So for different aspects, how is it done?
Okay, see, you are talking about, many things. So when you talk about like an entire system, so that is a different thing. You have to break up, like this course is not really about designing a very large system. This is about designing a converter, especially when you talk about your electric vehicle applications, because you talked about battery management systems and those things. So power electronic converter is the heart of the system. But as you know, that heart is very important, but the whole body is also there, right? So just with the heart, you cannot perform the functions, you cannot perform all the functions. So this course is about designing that power electronic converter. So for that, based on what converter you choose, and your voltage and current ratings and your switching frequency requirements and how much is the power rating. Based on that, you choose your devices and your whatever other passive components that you may be. So that is what this course is step by step choosing, is teaching you. For example, what we started with is the analysis. I mean, each module is like actually one step of design. So first of all, you analyze the converter. You have to understand its waveforms, what is the duty ratio, what is the modulation index, what all different types of modulation strategies can be used for that converter, what is the application for which you are using. So you have to understand the application and functioning of the converter. So that is the first step. Second step is that then you choose the components. So that's why the first module was an analysis, and the assignments, if you see, were based on selection of components. You have to select what is the rating of the devices you need, what is the value of L and C that you need. Okay, this is the first step. So you have chosen that. You have also simulated the system, and you saw what are steady state waveforms that you're getting. You should also see the transients. Of course, this course didn't cover the transients, but in an actual case, you are supposed to see the transients also. So all that, based on it, you choose the ratings of the components. Once you have chosen, then in power electronic converter, what is the most important thing are the selection of the devices. You have to choose your MOSFETs, IGBTs, diodes, whatever other devices that you're using. So that there you have to go through data sheets. You have to select the component. Select means you have to find out the part number, which you can buy from the market, and then based on it you can design the PCB and the converter. So you choose the device, then you design the drivers for them. Okay, so then after that you will have to protect them from over voltages. So then you will be also choosing snubbers, RC snubber or RCD snubber. After that, you also have to do the thermal design. What is thermal design? That you will see in the next module. Next week actually is on thermal design. So thermal design means what? You will be choosing the heat sinks and fans because you have to cool them. All right. After that, you will also have to do the magnetics design. Means you will be having some inductors or transformers. If you can get it ready-made, it's good. But if you cannot get it off the shelf, then you have to make it, or you have to get a custom-made inductor transformer. So that's the magnetics design. And then your design should also take care of a very big problem in power electronics, which is called as electromagnetic interference. Every step of design, your PCB design or converter design, any step one should be aware of electromagnetic interference. And then finally, after you have chosen everything, now you have to actually sit down, design the schematic and the PCB, and you have to test it, you have to perform the experiments, you have to verify whether everything is okay or not. All right, so in short, this is these are all the design steps. Okay, and the course week by week just progresses on each design step. All right, of course, this is for just a power converter, and this course is for beginners, people who haven't really done any converter design. But if you want to if you want to do a lot more in this, means you're not a first-time designer, you are a professional, an engineer, a power electronics engineer in some industry, and you've already done many designs, then you will know there are other aspects also. But that is not in the scope of this course, because this is designed keeping in mind beginners. Okay.
And there's also another question. As a student, we are right now working on MATLAB Simulink, and for the circuit designing or the PCB designing, we use Altium or Eagle. But those are the. But I think in industries, they are working on professional softwares. So, as a student, could you recommend something which could be beneficial for us apart from these tools or softwares?
means you want tools for which part? You PCB designing or for simulation?
For both. What?
So
Yeah,
for
and what
simulation, see, Simulink is an okay platform, but truly speaking, it is not a circuit simulator. But people do use your SimPower Systems toolbox there to simulate circuits. But traditionally in power electronics, you should use a SPICE simulator, like your LT SPICE is one of them, P-SPICE is there. So though in those actually you can put the model of the transistor or the diode, and that is likely to give you more something like device characteristics waveforms you may be able to see. So those SPICE based means your circuit simulators is what you can use. That's why in this course LT SPICE was chosen to show you the simulation of the circuits, buck converter and your edge bridge converter. And for PCB designing, there are many software available now. You can choose the one which you like. I mean, Eagle, of course, is very standard one. It's very widely used also. Apart from that, also there are many. It's all about, I mean, how much features you want and how expensive that software is. Okay, so, but initially it is a good idea to learn one of them. If you learn any one of them properly, others you can definitely learn very easily. Okay.
Thank you.
Yes,
Yes,
Arun
madam.
Kumar.
Yes, ma'am. Good afternoon, madam. This is Arun Kumar, ma'am. Can you able to hear me, ma'am?
Yes.
Yes, ma'am. Thank you. So we are much interested in this course, ma'am, power electronics, and I'm acting as a mentor for 67 students as an academician. So in the week 3, we have been discussing about optocouplers based gate drivers, and in week 4, pulse transformer based gate drivers, ma'am. So which is the most efficient, which gate driver is best suited for the converters? How we can take accordingly?
You know, I am not supposed to answer this question because you will put me in trouble if I say that this is good and this is bad, because the manufacturers, everybody claim that they are good. Okay, so I mean, optocoupler is also okay and pulse transformer is also okay. It is better to go by the specifications. What is your requirement, and whether that particular I mean driver is able to meet your specification or not. Optocoupler has got its own challenges, and pulse transformer based drivers, they also have their own challenges. They both have their own pros and cons. So you should not say that this is better or this is best. There's nothing like that. You just have to see the specifications and the pros and cons of that driver. So if you see that driver module, I have told about the requirements, and then I have told about what are the specifications that you should be looking for in a driver. So normally your current requirement, switching frequency requirement, propagation delay, that may be met by some of your drivers. But what really creates a problem is your CMTI, the common mode transient immunity. So that for some applications, it has to be very high. If it is not high, then you will have a lot of noise issues coming up. And driver is the part in the entire power electronic converter, which is like you can say is the problematic part. If you can design it properly, your converter will work proper. If you don't design it properly, then you will have unnecessary issues. You will not get it with what's happening. Why all of a sudden your converter started maloperating. Those issues can be there. So it's not correct to say optocoupler is good or pulse transformer is good. They both have their own advantages and disadvantages. You see based on your application what fits your purpose.
Okay. Ma'am, on behalf of students, ma'am, data sheet you are providing now. So will you provide in the examination through hard copy or soft copy, ma'am?
See, it will be an online exam. So mostly, I mean, whatever the question will be, if it needs a data sheet, the soft copy will be there in that question paper, the online exam.
Online exam. Okay. Ma'am, regarding first assignment, ma'am, we need solution to study. So students are asking the same, 67 students are there. So they're taking this course for credit transfer.
Oh, yes, yes, definitely. The solution was prepared, but there were some typographical issues because of which it got delayed to be uploaded. We'll upload it soon, the solution.
Okay, ma'am. Thank you. Thank you so much.
Yes, Rajesh.
Good afternoon, madam.
Good afternoon.
Can you able to hear me, madam?
Yes.
Yes, madam. Madam, I have one doubt regarding that data sheet, madam. Actually, in that that they have given that gate resistor, you have said that manufacturer details you have to take as an initial one, which is as actually they have example they have given as 1.2 ohms like that. Whether the gate current will be specified in the data sheet or we have to calculate based upon that, madam. That gate current will be specified in the data sheet respect to that MOSFET, because based upon that gate current only we are choosing that driver specifications.
No, gate current, most of the data sheets you may not be able to find out.
Okay.
You may see all data sheets are not same. Some give some details, some other give some details. But gate current, they may not tell. But what is important is the gate charge. That value is given. Most of the data sheets will give you the value of QG, how much is the gate charge. And also they give you the value of gate resistor for which they took those results. So those gate resistor value gives an initial idea of what is the RG value you can start with your design. I mean, you may use that or you may use something higher than that. But those are like some starting values or some like first estimate where to start with. And these values are finally decided after experiments. Use your IG is something is of theoretical interest. What is the value of IG? What is of practical interest in the design is what is the value of gate resistor that you need, and how much is the wattage of the gate resistor that is required, because that is what is finally what you need to put on the gate driver circuit. Okay. So for that you need the IG value, because then IG means your IG square R, that will give you the wattage of the gate resistor. So this I square R rating, first of all, your IG is not something like a DC. It's like a peaky waveform. Initially, it is there while it is turning on, and then during the time it is conducting, it's not there. It's close to zero. And then while it turns off, again, there is an increase in IG. Of course, it's in the opposite direction, but there is an increase in IG. So your I square R rating cannot be decided based on just the peak value of IG, because the RMS value of IG is going to be much lesser than the peak value. Hello? Hello?
Yes, ma'am. We are audible.
So Rajesh, I think he's dropped from the call. Okay, so next person can ask a question. Sanju.
Hello, good afternoon, ma'am.
Good afternoon.
Ma'am, I am Sanju Chaudhary.
Yes, please go ahead with your question.
Ma'am, actually, I want to know, in the recorded videos of yours, you have told the parasitic BJTs and diode in the MOSFET. How it appears in the MOSFET, ma'am?
See, that is more related to the physics of the device. How you get a parasitic diode and a parasitic BJT. In this course, I'm not taking it up. If you're interested, you can look through the physical structure of the MOSFET, and then you will get to know how a BJT is getting formed inside and how a diode is getting formed inside.
Okay, ma'am, but actually I watched so many videos on MOSFET, but no one told me about the parasitic BJT and diodes in it.
No, it's a very standard thing. You, which textbook are you following for this? You can look into
I'm just
a textbook by Professor Ned Mohan on power electronics. Okay, there your power MOSFETs are covered in detail. The physical structure is also covered in detail, and it talks about everything. Okay.
Ma'am, will you please repeat the author's name?
You can also read Jayant Baliga. Okay, on semiconductor devices books are there. There also, although I think that book is more discussing IGBTs. I forgot the name of the book by Jayant Baliga. Okay, that book also covers a lot of things, the device physics associated with semiconductor devices.
Okay, ma'am.
Okay.
Okay, thank you, ma'am.
Yeah, Priya, please go ahead with your question.
Good afternoon, ma'am. Ma'am, my question is, in the data sheet, they will provide maximum and minimum values and typical values. So when to take maximum value and when to take typical value, that's the confusion I have.
Well, I mean, which maximum values you have to tell about the particular specification. Because some of them you can go by
For example,
typical, some
QD,
of them
ma'am.
you can go by maximum.
If we take it.
What is it?
Okay, if we take a value of QD, total charge,
Yes,
total gate
you
charge.
may go by the maximum value for your design. Because always there is some over designing done. Some margin is always kept. You can take the maximum value.
Ma'am, for example, in the V3 assignment, you have given a question VG 15 volts, and in the data sheet, VG is restricted for 10 volts, not more than that. So during that time, typical and maximum values are given. Maximum value is 270 and typical value is 180. So we are in confusion to choose which QD for that. So like if gate value is more than that.
Assignment, which assignment did you say?
Week 3 assignment, ma'am.
Week 3 assignment. Okay,
yes,
let me look into it. So it clearly says that the maximum value of total gate charge. The second question.
Not that one. No, ma'am. No, ma'am.
Yeah, so that is the value you are supposed to use further for your calculation.
Oh, okay, okay. So
okay,
yeah,
that is why you are asked to note down those from the data sheet.
Okay, ma'am, fine. But VG value is greater than given value, no, ma'am?
See, if you want to know what is the QG associated with your 15 volt, you go through the graph that should be given. There is that graph, your QG versus your voltage, that is provided in the data sheet. Okay.
But in the data sheet, Yeah, ma'am. I saw that graph. Actually, in your videos, you told to choose power, gate power. We have to choose that graph. We have to look into that graph. But that graph is restricted for only 12 loads. In the data sheet, graph is given only till 12 loads of VG. But yeah, in the problem, the VG is 15 loads.
Yes, so that is, these are all estimates. No? These are all estimates.
Okay. So if that is the case, then we have to choose always maximum value.
Yes, you can choose maximum value to start your design, means to get the initial value of your gate resistor. You can do that.
Okay.
See,
Ma'am,
what
and one more
question
thing
that you
is,
are asking, I'll tell you what is the problem. The problem is that your design of power electronic converters does not go strictly by these theoretical calculations. There are numerous non-idealities that are associated in the turn-on and turn-off process of any device. Okay, so whatever they gave you, the data sheet, that is based on the design of the converter they performed. Okay, now it is too early for me to explain you those, that what are the non-idealities and why it happens and why this is an estimate, why you cannot say that these are exact calculations. It is very difficult to explain those things in the beginning. So that's why, to make the assignment simple, some value is given to you so that you get an idea how these calculations are performed, so that you are able to get your first estimate for the design. Okay, and finally, what is the value that you will choose? That is something gets decided when you perform experiments. Okay, so this is a course which is more related to practical design. And before actually practically doing it, you have to know a lot of theory and you have to know how to perform some calculations. So those things are being told to you how to do it. But finally, what you choose, that will be something when you perform the experiment, you actually design it, then you will know that. So, but you have to reach to that stage, and for that only these things are being told, that how do you do, how do you reach to that stage, and then you will actually understand what's the difference between your this practical design and why you cannot do a perfect calculation by using theory, why it's only an estimate which is possible.
okay. Okay, ma'am.
Okay.
Thank you.
Yes, this course is more related to practical design, and this is a MOOC course. It is not possible to give you hands-on experience. Only demos are going to be given. If you have facility at your end, I would really suggest you, advise you that you do the design. You actually practically design a converter and test it, and that is when you will be getting the most benefited by this course.
Ma'am?
Yes, who is asking the
Venkatesh.
question?
Venkatesh, ma'am.
Yes, please go ahead.
Ma'am, actually, last first week we used LT Space software to simulate a buck converter. Is fine, and I used MATLAB also. I got the results, but how to see the actual waveforms, ma'am? That semiconductor devices, that reverse recovery, and how to see those non-idealities in software, ma'am? Which software is best to see those waveforms?
Some of the non-idealities you can observe using LT Spice. For that, what you have to do is, whatever device you have chosen for your design, you get the spice model of it. The manufacturers, if you go to their websites, you will be able to get a link for the spice model. They provide the spice model for the particular device, and that spice model then you have to import in LT Spice. And then you can use that model to do the simulation. So some of the characteristics, switching characteristics and non-idealities, using those models, you should be able to see.
Okay, ma'am. Sure. Thank you.
Yeah, Priya, do you have more questions? Priya, I see your hand still raised. If you have more questions, you may go ahead with the question.
Ma'am, will you please re-evaluate the first quiz, ma'am?
Yes, it is being re-evaluated.
Yeah. Ma'am, and one more thing, I have a doubt in first week quiz. So actually what happens there is they ask for output voltage. According to your videos, output voltage is nothing but capacitor voltage. So output voltage given in the question is 30 volts, but they evaluated the answer for 30.3 volts. 30.03 volts. So there's a confusion with that. Why it is 30.03?
Because you also have to take into account the ripple in the capacitor voltage. There is an average output voltage.
Okay.
There is a ripple
Okay,
in it, so that you have to take into account the ripple also.
Okay, ma'am. And even inductor value also, ma'am. 22.5 I have given as an answer, but you evaluated for 25.56, 22.56.
Okay, you
With,
will be getting the
0.01
solution
difference.
very soon. The solution will be uploaded, and you can look into it.
Sure.
Okay, and if you still have
Sure,
questions,
sure.
you can email. The TS will answer that.
Sure. Okay, ma'am. Sure. Ma'am, it's a personal question. Shall I ask, ma'am?
Yeah. If you are comfortable in asking in front of everybody.
I'm comfortable, ma'am, with your permission. Ma'am,
Yeah.
I'm actually I want to do PhD. So will you give assistance for that, ma'am?
No, assistance means what type of assistance you are expecting? If you want to do PhD, you apply and then you prepare for the exams.
Yeah.
Okay.
Ma'am, are you from IIT Guwahati?
I didn't get it. About what are you asking?
Ma'am, your institution, ma'am.
Yeah, I'm from IIT Guwahati.
Okay, ma'am. Thank you.
Yes, please go ahead with your question.
Good evening, madam.
Good evening.
My first question is, madam, related to the buck converter, madam. Whenever you switch off the buck converter, so you did the analysis that inductor and output voltage is there, madam. So my question is here: whenever inductor in the first step switch on position, it act as a load. Actually, it is charging. So whenever it is recharging, so it will change its terminals actually. So whenever current direction is plus and minus means whenever it is act as a source, it will change its terminals, and the output voltage it is getting as same VL is equal to V naught. Is this analysis is correct or not, madam? Whatever I told just now. Whenever it is acting as a source, it will change its direction, current direction.
No, actually, by explaining like this, it is very difficult to understand what you are telling. If you can draw the diagram and then tell, then it is easier.
Okay, madam.
Okay, by verbally telling, it's very difficult to understand what exactly, which direction of current you are telling and what switching you are telling. It's better to draw the diagram and then tell. Okay, so you can draw it and.
Okay, madam. I will go to the next question, madam. Second one is in the buck converter, whenever we are designing, we have to make two assumptions. The first one is average voltage across the inductor is 0. So the reason you told that in case if you are not assuming that inductor voltage is 0, or that inductor current it is continuously increasing, it is you told that it may continuously increase and it may at some particular point the inductor may damage like that continuously increasing current. So what is the reason, madam? Average current through the capacitor also you taken 0 in the assumption. So if not taken 0, what will happen, madam? The second assumption.
It is similar. It is similar. If in case of inductor, your average voltage across the inductor is not 0, then that lead to saturation, your increase in the current. Similarly, if the average current through the capacitor is not 0, that will lead to increase or decrease in the capacitor voltage. So if you want to maintain the voltage across the capacitor, then the average current through the capacitor has to be 0.
And one more last question, madam. So you told about the unipolar and bipolar two types of pulse width modulation you have discussed, and you told that your unipolar PWM we can use for higher frequencies. Can you differentiate exactly what range of frequencies can we use unipolar and bipolar? Can you elaborate that one, madam? What up to what frequencies we can use bipolar, and up to what frequencies we can use unipolar like that? Can you make one statement?
See, your unipolar or bipolar, up to what frequency you can use, that is not dependent on the modulations, just on the modulation strategy. It depends on the power rating of your converter, the voltages and the currents it has to handle, and what type of devices you have or you're going to use. That decides the switching frequency.
In case, madam, my application require high switching frequency, then obviously I should go for unipolar switching, unipolar PWM technique only, na, madam. Is there any other constraint shall we consider?
No, we cannot just say like this. Unipolar has got several advantages, but when it comes to solar PV applications, the requirements it has, the unipolar has got some disadvantages also. So there people don't prefer unipolar PWM. They modify that PWM method. They don't actually use the bipolar also, but they modify the unipolar PWM also and use it in a slightly different way. So, I mean, straight, this cannot be, I mean, a general answer cannot be given like this. You have to look into the application. You have to look into various aspects of the application. And then you can decide which is the modulation strategy which is better for you. A general answer is very difficult. And it's actually not right to give a general answer. It is very much application dependent.
No, madam. Just I would like to I would like to know one thing, madam. For example, my application is require high power rating and less switching frequency. I will generally go for BZT. Like if my application requires some less power rating and high switching frequency, generally I will go for the MOSFET. So like this, can you decide one particular thing based on these things, unipolar and bipolar?
See, for your I mean, single phase output applications, if it is not PV applications, then I mean, many of the places people go for your unipolar PWM. In fact, they don't prefer bipolar PWM. Why would you do bipolar PWM if you're getting the double the switching frequency in the output by switching it at the same frequency on the switch side? Then you will be going for unipolar.
Yes. Okay, that's all, madam. Thank you. Thank you.
Hi, ma'am. I'm Purnesh here. Ma'am, my question is like if MOSFET datasheet doesn't give jet current, how can we predict like we can iterate the things, or is there any method to find out the jet current? We have to simulate the things, or and we have to note it down, or is there any other method? to find the exact gate current which is required by that MOSFET?
See, I had given some more equations in the video.
Yes, ma'am.
Okay, they were also approximate equations.
Yes, ma'am.
Similarly, there are some other equations also which you may find out in the application notes by some of the manufacturers.
Okay, ma'am.
They all are approximate equations.
Okay.
You can use and you can see what values of IGs you are getting.
Okay, ma'am. Okay. IG's IG's impact in which parameter it might impact? On what parameters? Like it may impact in gate voltage or something else. Like what I can say.
It's not the IG. It is the QG which has to be met. It has to be satisfied. So when you have the transistor, so in the gate to drain region or gate to emitter region, you have to charge the capacitor and discharge the capacitor. So how quickly you do that or how slowly you do that, that decides your IG.
Okay, ma'am. Okay, clear.
Okay, and IG is also affected by the value of RG.
Yes,
if you choose large RG, then your IG will obviously come down.
Come down. Okay, 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 ma'am.
Okay.
Yes, ma'am.
Okay, one more last question if anybody is having. It's already time. So if anybody is having any question, just one more question I'll take up. Yes, please go ahead.
Madam, MOSFET has having RDS is very high. It is inherently is having or because of any other reason, madam. RDS generally
It is high because it's a majority carrier device. Whenever a device is a majority carrier device, your on-state resistance will be higher.
Can you elaborate, madam? What will happen if the majority carries RDS?
Yes, that is associated with the device physics. Okay, so that I would not like to discuss in this course. That if you are interested, you can see what is the difference between majority carrier device and minority carrier device. So you'll get lots of answers on Google or even in standard textbooks they are giving.
Okay, madam. Minority carriers means RDS is less, no, madam. If it is a.
What is it?
If the device is minority carrier charge.
If the device is majority carrier, means either the holes or the electrons are responsible for the conduction. Okay, if it is minority carrier, means both of them are taking part. Both holes and electrons are responsible for conduction.
Okay. Okay, madam. Thank you.
Okay, all right. Thank you for joining this live session. And
thank you.
I hope you all will enjoy the rest of the course as well. And we'll have another live session later on towards the end of the course. Thank you.
Thank you, madam. Thank you very much.
Thank you for the time, ma'am. Bye.
Thank you.